Hello guys, welcome to the second edition of Discrete Probability. This will be my homework version for my statistics class here at Texas Southern University in Houston, Texas. And today we're going to be going over the same concepts, a little different information here for the homework edition for Discrete Probability. Other than that, let's go ahead and get started. So as I mentioned before, discrete probability distribution is characterized by a probability of mass functions that is commonly used in computer programs which help make equal probability random selection between a number of choices. Some examples are number of students that scored B in a particular class or course, a coin being tossed 4 times with the possibility of it being heads, or the number of commercials that are about 30 seconds that appear on MBNC from 5 p.m. to 7 p.m. In the next slide, we're going to be doing an example of discrete probability and the two variables that we're going to be using from the real estate data set that we have been provided by my wonderful statistics teacher. So for this example, we're going to be figuring out the possibilities of two variables this time. For this one, we're going to be selecting the bedrooms and the price of the house if it's under 200,000. So we're going to be determining the outcome of these two variables here in the next couple of slides. So for the first variable, we're going to have the bedrooms of the house. The way we're going to set this up is due to the bedrooms having more than at least 6 bedrooms in each house. I mean, the biggest one, the greatest amount that a house has is about 8 bathrooms. So we're going to be splitting that in half, basically. So we're going to see the houses that have 4 bedrooms or less, and we're going to see how many houses have 5 or more bedrooms. We're going to be examining the possible outcomes from, again, locations of the townships 4 and 5. As you can see here from the data input table that we have been presented, a vast majority of houses that have 4 bedrooms or less in Township 5 has a very low amount of houses with 5 bedrooms or more. From the data set, we can conclude that 38% of houses with 5 or more bedrooms is the probability for this outcome, which is 1 in 17th of the data set here, and roughly 62% of houses in townships 4 and 5 combined have a 1 in 20th probability outcome of a house with 4 bedrooms or less. The next slide will be determining the possibility outcome for the prices of the houses. Next, we're going to be determining the possible outcome of the prices of houses in the data set. We're going to be using township locations 1 and 2 for this data set. We'll be guessing what is the probability outcome of the township of houses that's under the selling price of 200,000. And so here we have the house price table data set. As we can see from the table above, we can conclude that this chart gives us a possible greater outcome of the houses that's well over 201,000. That's the greatest possibility outcome of 60%, as you can see on the table below. That 60% of the data from townships 1 and 2 combined is roughly 60% of the data. That's 1 in 20. If 1 in 21's outcome, the possible data. As you can see, 53% of 8 houses in township 1. That's 53% roughly of the data that has under $200,000 worth of the house. So this is the probability discrete outcome for all the house prices for the data that's inputted in the data chart. So that will really conclude for this series of discrete data. I hope you guys are finding these videos very informative. This is my first year taking statistics, and it's a very, very good learning process for me. I've learned so much from doing these videos. I was actually kind of, getting lonesome, trying to do these videos, but they're really entertaining and very informative, and I think you guys will learn kind of the grasp from these videos. So without further ado, guys, thank you for tuning in, and I'll see you guys next week. Thank you.